Hello everyone, and today is the part 4 of the particles. And today we will manipulate our particles, but not through the DOP node. We will use the DOP network, exactly POP network, but we will give the attributes at the SOP level to the particles by the attribute VOP node. And we will create a firework, a spark-like effect by particles. And this video is really important for this series because if you want to understand particles at a deeper level, that we need to understand, we need to know how we can manipulate our particles at the SOP level, how we can give attributes at the SOP level. So to finish the particles, this will be the last video of this particle, and in the end I will create particular projects for each concept. So let's dive into this video, and first let's create a circle. And this is a polygon circle, and we have something like this. And let's say z-axis plane, so the y-axis, the normal face, is in the y direction, and you can increase the divisions, and we have this plate-like shape. And what we can do now, we can scatter some points. Now I have some points from this plane, circle plane, and what I can do now, in the scatter uh, parameters, I can just turn off the relax iterations, so we can have some like dense particles at some areas, and I don't want this much particle count, so I can say, let's say 10 is enough, and I will show you why. You can decrease the radius, and here you have the global seed, right? And just give this some value according to the time frame, so we can have some variations here at every frame, but we don't need to do it now, but just keep this in mind that we need this. And we have the scatter, and let's give attribute VOP and POP network. So this is for the simulations. If we have any existing attribute that can be simulated, we need this if you want to simulate these points. But these points don't have any attribute. These points don't have any attribute, any existing attribute we can use to move these particles, or we can do to simulate these particles. What we can do here right now, we can go into the attribute VOP, and today we will talk about this attribute VOP but in a deeper level, and we will create some attributes at this level, and we can manipulate the particles by the attributes we will give here, and we don't need to go inside and give some forces, extra forces. I will give the extra forces, but our main focus today is this. So to visualize our particles better, just give this a pop color, and this is just a visualizer. So say this ramp and inferno, and in the source part we can say all points, and birth, I want the life expectancy to be 2. So now after 2 seconds these particles will turn yellow. I have talked about this in the particles video if you want to know more about this. And let's say 1, and the pop color, we have the ramp is set to an age, which is life. I have also talked about this earlier. So just turn this off, and we can have something like this. Okay, now inside this attribute VOP, the first basic example is give these points some velocity. what we can do, we can just add a constant and connect this constant into the velocity of these. And for the velocity is a vector, so we need a vector constant, and we can just connect this to the velocity, and let's say 3 float vector. And so we have a velocity in the y direction, and when you will see the visualizer, you can just right click and you can just turn this visualizer on for the velocity attribute, and you will see something like this. We have something like this. Inside this we have this velocity which is going into the velocity. And when you say pop net 2, you have the source, and in this source we have the attributes, and currently we are using inherited velocity, which is this velocity that already exists on these particles. So just play this and you will see your particles are moving in the y direction, and after 1 second they are turning in this color. They take birth in black, and after their life at the end they turn this because of this pop color, like this is the bright yellow color, and we are seeing at the end of their life. So we have these particles moving in the y direction. Now what if I want to move them away from the center? What we need to do that? We can just delete this, right? Toggle the velocity visualization, and what we can do, we can just subtract. In the last video we used subtract, and that concept is really beneficial here also, and we can use the same concept to draw a vector. What we can do, we can subtract we can subtract the input 1 to a constant, and which will be a 3 float vector, and it will be their position, right? We can just say position, and we can connect this into the velocity. We will have something like this. And what is happening here, because we are subtracting the input 1 here, input 1 is the point position and input 2 is the center. Now we are subtracting the center from input 1, that's why we are getting this direction. And when I first used the subtract in the last video, when we were talking about particles at the very beginning of this, I have talked about this, so I won't go deeper into this. But here the main thing here is, when you decrease this value, now this constant we are subtracting is getting down, so we're getting this direction. And I have this, the output is going into the velocity, and when I play this you will see something like this. So this is a very basic concept, and we need to go through this like it's a very common drill to do, and we are seeing something like this. Now what I can do, I can go here at the scatter. Now you see their birth is like constant. What if I change the global seed, and you will see our points, turn the visualization on to visualize them better, and you see now we have like different global seeds, so we can have more variation. We can animate this, we can give this keyframe. At first I want 0, but with each time I want to multiply this by a value 2, let's say. So this is changing by the 2. This $t means per frame multiplying by 2. So the value we are putting into the global seed, we have something like this. And you see the total for the total force total count of these, that means the particles count in total. We can animate this also. So at the starting frame it will be 10, and at the, let's say, 10th frame I can say it will be 0. So they will, oops, 0, and they will take birth and they will just disappear with the random seeds. So we have two animating values, so we can have the variations in the particles. And now we have something like this, right? Inside this we have the simple value which is going into the velocity. What if I want to give this a noise also, so we can have some random velocity values and direction. To give the noise, I can just add a turbulent noise. We can add curl noise also, but here turbulent noise works also fine. So you can just duplicate this, and the positions will go into the position. And we have this amplitude and offset ports here. We will use the offset one. So what we are doing here, we are offsetting the values at different location. Like now when we are using the offset, now we are sampling the values, but after offsetting the values will be changed because we are changing the positions of these values of this noise. So offset here, well, let's say we have time and frame, and this offset also wants a vector. So we have time and frame. Time is a float and frame is integer. We can use both, but frame, let's say, use time. And I have this float to vector, and this float to vector is giving this a vector, and we can add this value to this. So we can see, we can increase or decrease the frequency, and we can amplitude, you can say something like that. Frequency, you can increase or decrease it as you want. We have the roughness and amplitude, something like this. And this float to vector, what is this float to vector doing here? This float to vector is giving this a value, but what value? Let's say if time is equals to 2, the vector will be 2, 2 and 2. So this value is going into this offset, and now we are offsetting this by this value, and we are sampling the value at that offset. Offset is like we are reading the values, but at different location we are changing the noise location, and we will see something like this. Points born, they have different, like their velocities, vectors, and they will just die. When I toggle this on, you will see we will have something like this. They will born and they will die. We can, what we can do, we can add a multiply also here. So we can increase this whole value. We can multiply this by some number, and we can like enhance, we can increase the velocity value. And to do this, just say 2, and we will have something like this. And what we can do more here in the popnet, we have the source and we have this birth. We don't need to change the life expectancy. It is it's okay, but we can add a gravity. We can add the gravity force, so we these particles will fall down eventually. right? The velocity is slightly lower. We can increase, let's say 5, and when we go back, we will see something like this. It's still uh, it's the velocity is still low. And what we can do here, how we can change the velocity without going every time here, we can change this in the source first input, in the source pop node here also, because we are sourcing the inherent velocity here. So we have this attributes and we are using inherited velocity, and this we have inherit velocity value. We can say, let's say 5, so the inherited value will be multiplied by 5 and we will have something. And what is happening here is, you see, when we have the inherent velocity 0 and we have inherited velocity 1, these particles are moving. These particles are not at their original position. And what is happening here is, because we are at the frame 1, not frame 0, frame 1s we have some value, and that's why we are seeing them to take birth right there. We can just say inherent velocity, but we can say 1 or we can say 0. And if we play this, you will see nothing because we are multiplying this by 0. We can say 1, we will see something like this, but we can turn the guide off just for now. And we have add to inherent velocity, we have set initial velocity. So we can add the variance and we can add more velocity here also in the inherited velocity. So for this, I will just use the inherited velocity and the initial velocity will be 1. We will have this, but it's okay for now because we need to understand these concepts for this video. So we will see something like this. And I can just increase the velocity, let's say 10. We will have something like this. You see, these particles will eventually fall, right? And I guess this is it for this video. Just remember these nodes, how the inherited velocity works and how everything connects together. You just have to understand how we can change, how we can give this some velocity, some attributes at the attribute VOP level, not in the pop network. We just give this a pop color and this gravity, nothing. I guess this is it for this video. Just remember this, create this network on your own, copy it and play with it, play with some parameters, and just know how these things work, how we can inherit the velocity, how we can give the velocity at the SOP level. And I will see you in the next one. Until then, take care.